Next is the cases of simply supported beam. Here we will see some cases of simply supported beam. So case 1 is simply supported beam with load at mid span. So this is the first case of the simply supported beam. So first of all, we will draw the figure of simply supported beam with load at mid span. See this simply supported beam which having two supports here. First is A and second one is B. This simply supported beam having span of capital L. See this. This is the span of simply supported beam and that is capital L. Now what is statement of this case 1? Simply supported beam with load at mid span. So at mid span, this is the point of the mid span. We will consider that point as point C, and at this mid span there is a load of capital W, or there is a load of W is acting at the mid span. So at mid span of simply supported beam, the load W is acting. So as the load W is acting at the mid span, so this distance A to C, or the span A to C, is L by 2, and the span B to C is also equal to L by 2. Now next step we have to do, that is we have to find out the support reactions. So at A the reaction is RA and at B the reaction is RB. So these two reactions at the support first we have to find out. So we will write here to find RA and RB. Here first we will take summation f of y. Summation f of y is equal to, we can write here RB, that is plus, then W, that is minus, then RA, that is also plus. So here we will take downward as minus and upward will be plus. So RB is upward, so it is plus. W is downward, it is minus or negative. Then RA is upward, then RA is positive. Now by applying condition of equilibrium, summation f of y is equal to 0. So we will write here RB plus RA minus W. Then we can write here RA is equal to, if we shift W on left side then it will be plus W, and if we shift RB on the left side then it will be minus RB. So RA is equal to W minus RB. This is equation number 1. Next we will take moment about point A. Now see here, if we take moment about point A, then moment of RA will be 0. Next, moment of RB, and that moment of RB should be equal to RB into capital L. Capital L is what? It is a perpendicular distance of this reaction RB from point A, but this moment is anti-clockwise with respect to A. So this anti-clockwise movement will be taken as negative. Next we will take the moment of this load which is acting at the mid span. That load is capital W, and the magnitude of the moment will be W into L by 2. See here, W into L by 2 is what? It is the perpendicular distance of this load W from A. Now direction of movement. See here, with respect to A, this W is having movement clockwise, so it will be taken as positive. Next step we will do here, that is by applying condition of equilibrium, moment about point A is equal to 0. So 0 is equal to minus of RB into L plus of W into L by 2. If we shift RB into L on left side, then it will be plus RB into L is equal to W into L by 2. This L will get cancelled. So RB is equal to W by 2. So we will write here RB is equal to W by 2. Now if we substitute this RB is equal to W by 2 in equation 1, then we can write here RA is equal to W minus of RB is what? W by 2. We are substituting this RB is equal to W by 2 in this equation 1. So we will write RA is equal to W minus W by 2. Then we can write here 2W minus of W divided by 2. Then we can write RA is also equal to W by 2. So we can write here RA is equal to W by 2 and RB is also equal to W by 2. After finding RA and RB, next step we can do here that we have to do the shear force calculations to draw the shear force diagram. Now see here, these are the sign convention for shear force. So now we will write here shear force calculations, that is SF calculations. So we will start from our right, then we will move to left. So on the right, the first is this support B, that is point B. Now see here, first we will take shear force just right of B, shear force at a section just right of B. See here, just right of B is this section here. See on the right side, no load is acting, so shear force at a section just right of B is equal to 0. Next we will take shear force at a section just left of B. So see this is a section which is just left of B. See on the right side, there is a load acting and that load is RB. On the right side of a section, this load RB is acting in upward direction. So see this sign convention, on the right side of a section the load is acting in upward direction, so it will be taken as negative. So we will write here minus of RB. So we can write here it is minus of W by 2. Next we will take section which is just right of C. So shear force at a section just right of C. This is the section just right of C. See on the right side, there is a load RB. On the right side of a section, RB is acting in upward direction, so it will be taken as negative. So it will be minus RB. So it will be minus of W by 2. Next we will take shear force at a section just left of C. See this, just left of C. Now see on the right side, this is the section which is just left of C. See on the right side, first is RB. On the right side of a section, RB is acting in upward direction, so it will be taking as negative by this sign convention for shear force. Next load is acting on the right side is W, and this load is acting in a downward direction. So right side of a section, the load is acting in downward direction, so it will be taken as positive. So RB will be negative but W will be positive according to sign conventions for shear force. So what is RB? W by 2. So here it is minus of W by 2 plus of W. Then the answer of minus of W by 2 plus W, that will be equal to W by 2. Next we will take the shear force at a section just right of A. See here, just right of A is this section. See on the right side, the first load is RB, and this RB is acting in upward direction. So right side of a section, RB is acting in upward direction, so it will be minus RB. Then this W, which is acting in downward direction. So right side of a section, the load is acting in downward direction, so it will be positive here. See again, shear force at a section just right of A. See on the right side, first load is RB, second load is W. RB is right side of a section acting in upward direction, so it will be negative according to the sign convention for shear force. And the W is acting in downward direction, so right side of a section, the load is acting in downward direction, so it will be taken as positive here. So what is RB? RB is W by 2, so minus of W by 2 plus W, and that should be equal to W by 2. Next we will take shear force at a section just left of A. Shear force at a section just left of A. See here, this is the section just left of A. See on the right side, first is RB, so RB will be negative, right side of a section acting in upward direction. Next is load W, that will be positive, load W right side of a section acting in downward direction. Then this RA, the support reaction RA, see on the right side from this section which is just left of A, there is a first load is RB, second is W, but third load is here on the right side of this section, that is RA. So right side of a section, this RA is acting in upward direction, so it will be taken as negative. Now what is RB? RB is W by 2, so here minus of W by 2 plus W minus of W by 2, and if we calculate this, then minus of W by 2 minus of W by 2, it will be minus of 2W by 2, then it will be plus W, the remaining plus W will be right here. Now here this 2 will get cancelled, so minus W plus W should be equal to 0. So these are the shear force calculations for this simply supported beam with load at mid-span. Next we will draw the shear force diagram. Now to draw the shear force diagram, first we will draw the baseline. Say this baseline here. On this baseline, this is point A, this is B, and this is point C. Now we will plot the magnitudes of shear force here. So negative magnitude will be plotted below the baseline and positive will be plotted above the baseline approximately. See here, shear force just right of B is 0, so that will be on the baseline here. Left of B is minus of W by 2, so that will be below the baseline. It is minus of W by 2. Next, shear force right of C minus of W by 2, so that will be below the baseline here. So this is point C, so we will plot that here. It is minus of W by 2. Next, shear force left of C, it will be plus W by 2, so it will be above the baseline. It is plus of W by 2. Next we will plot the shear force just right of A, that is also plus W by 2, so it will be above the baseline. So here we will write plus of W by 2. Next, shear force just left of A, that is 0, so we will plot that on the baseline. Now we will join these points here. So first we will join shear force left of B and right of C. So left of B minus of W by 2, right of C minus of W by 2. There is a no loading between B and C, so the shear force diagram will be the horizontal straight line. Next we will join shear force left of C and right of A. Left of C plus W by 2, right of A plus W by 2. There is a no loading between A and C. So the shear force diagram will be horizontal straight line. So plus W by 2 plus W by 2 will be joined with horizontal straight line. Next we will join right of A, left of A, that is 0 and W by 2, right of C, left of C, plus W by 2 and minus of W by 2, and right of B, left of B, 0 and minus W by 2. So we are closing the figure here. See, this portion is above the baseline, so it will be positive. This portion of shear force is positive and this portion is below the baseline, so this portion is negative. So this is the shear force diagram for this simply supported beam with load at midspan. Next we have to do the bending moment calculations to draw the bending moment diagram. So these are the sign conventions for bending moment. So we will write here BM calculations, that is bending moment calculations. So first we will do the bending moment calculations at the supports of simply supported beam. So there are two supports of simply supported beam. As there is a no couple is acting at the supports of simply supported beam, then the bending moment at the supports of simply supported beam will always equal to 0. So here at support A and B there is a no couple is acting, so bending moment at A and B, bending moment at A and B of this simply supported beam will be equal to 0. So as there is a no couple is acting at the supports of simply supported beam, because of that the bending moment at the supports of simply supported beam will be equal to 0. So moment at A and moment at B will be equal to 0. Next we will calculate the bending moment at C. Now see here, this is C point here, and the moment of this load W with respect to this C point will be equal to 0. Now see, on the right side of C there is only one load, that is RB. So the moment will be, the magnitude of the moment will be RB into L by 2. Now see here, on the right side of this C, this RB will having anti-clockwise movement. So see here, on the right side of this section, if the moment is anti-clockwise, then the bending moment is positive. So here this bending moment at C will be positive here, that is RB into L by 2. Now we will write here RB is equal to W by 2 into this L by 2. Then we can write it will be WL by 4. So bending moment at C is equal to WL by 4. So these are the bending moment calculations. Now we will draw the bending moment diagram. To draw the bending moment diagram, first we will draw the baseline here. See, this is the baseline and this is point B here, this is point A and this is point C. Now the bending moment at A and B are equal to 0. Next we will plot the bending moment at C, and it is plus of WL by 4, so it will be above the baseline. So approximately we are plotting that here. It is WL by 4. Now we will join these points here. First we will join B and C. There is a no loading between B and C, so the bending moment diagram will be inclined straight line. bending moment diagram will be inclined straight line. Next we will join A and C. There is a no loading between A and C, so the bending moment diagram will be inclined straight line. Now this is the bending moment diagram. Next, this whole portion is above the baseline here, so you will write here this is positive, and then we will write here this is the bending moment diagram, that is BMD, for this simply supported beam with load at mid span. So these are the shear force diagram and bending moment diagram for the simply supported beam with load at mid span. So this is the case 1 for the simply supported beam.